All right, so in calculating differentials, what we've learned so far is the following. We've learned like dy dx is equal to, let's just say 3x squared, right? Like we took a derivative of something and we got dy dx equals 3x squared. Well, differential form is basically this. They say dy is 3x squared dx. What did they do? They just what? Well, they took a derivative, but to go from the blue to the green, they did what? They multiplied the dx over, right? That's all they did. That's the only thing that's new for you guys besides a little bit of a notation. But that's basically all they did. And that is called differential form, okay? So this is differential form. All right, so that's basically the new thing. So again, it's not like it's anything brand new. You guys already know how to take derivatives. You just got to remember to move the dx over. Now, some of us will do the derivative like normal and then multiply by dx. Some people will say, well, that dx is going to end up on the right side anyway, so I'm just going to move it right away. That's completely up to you how you want to do it, but it does have to look like the green part. Now, just so you know, dx is the differential of x just like dy would be the differential of y. So like dt would be the differential of what? T, right? dA would be the differential of a, so et cetera, et cetera. So very easy idea, okay? So basically what they're saying is if you're going to take a derivative dy dx, which is the same as saying f prime of x, right? So dy dx would be the same as saying f prime of x. They're saying, look, you can rewrite it so it looks like this. dy is equal to f prime of x dx. Now just a quick note. And this is, like I said, a quick notation thing. If you see delta x, that basically means dx. And if you see delta y, that means dy. Okay, so they're both differentials. So if you happen to see that in the homework, don't freak out. It's just the same thing. In the homework, they actually mention both together. But when you see it, it's the same idea. Okay? So basically, same ideas. Oh, thank you. Scratch paper. So, are we okay so far? Nothing major? Nothing scary, hopefully? So, let me show you how we do these problems. So, example number 1. Let y equal x cubed. Find dy when x equals 2 and dx equals 1/4. So basically all you're going to do is take your derivative, okay? So since y is equal to x cubed, then dy is equal to, the derivative of x cubed is 3x squared, and then I'm going to put dx after it. Now, if you want to write dy dx equals 3x squared, go ahead. But just don't forget to get the dx portion and move it over. Okay? Now we plug in the information that's given. So dy is equal to 3 times x, that's 2 squared, times dx, that's 1/4. So that's 3 times 4 times 1/4, which means that the answer is 3. And we're done. So my differential for y is 3. Questions on this one? I mean, pretty straightforward, right? Just take your derivative that you already are supposed to have practiced a couple times by now, right? And plug in the numbers, and let's see what you get. So we can also just do basic differentials without plugging anything in. So they might say something like this. Example number 3. Sorry, number 2. So they might say find the differential and they give us something like y equals sine of x. So the differential of y equals sine of x, so dy, would be equal to, what's the derivative of sine of x? Cosine of x, and then just write dx, and you're done. Notice the only difference is that instead of writing dy dx equals cosine of x, I'm writing the dx on the right side. Right? So it's nothing like a big major change. Now, the rules still apply, as in, like, you could still use like power rules and chain rules and product rules and stuff like that. So here's a product rule problem. X times cosine of x. So I'm going to take my derivative, okay, or my differential, and I'm going to write dy equals. Now I know there's going to be a dx at the end, but I'm just going to wait till after I'm done. So x cosine of x, the derivative of x cosine of x. That means I got to take the derivative of x first, okay? So derivative of x is 1 times the second function plus, okay, now write the first function and then take a derivative of the second function. So x times negative sine of x, and then I'm going to write dx after it. Now let's simplify the inside. Dy is equal to cosine of x minus x sine of x dx, and I'm done. Now this next one that we write up, I'll give you a little bit of time to kind of write that down. But the next one that we do, we're going to do it the way we normally are used to doing these problems. Let's try this one. Y equal to 1 over x. Now remember, I tell you guys, whenever you have something like this, it might be better to get that denominator and move it up. So if you want, you can rewrite it as y equals to x to the negative 1. Sorry, no, negative 2. X to the negative 1. It'll make it easier. That way you don't have to use the quotient rule. We just got to use the power rule. So look, dy dx. Notice I'm not doing the differential method, but I'm just gonna do a basic derivative, and then after I do that derivative, then I'm gonna move the dx over. So the derivative of x to the negative 1, that's negative 1 x to the negative 2. So dy dx is equal to negative 1 over x squared. But again, they want the differential, so I'm just going to get that dx and I'm going to throw it over to the right side. So dy is equal to negative 1 over x squared dx. And that's my differential. All right, so we'll do one more and then I'll let you guys go over the homework and stuff. But let's do one more. Maybe something that has a chain rule in it. So part D. we're going to still find the differential of this right here. So x squared plus 1 to the half. So notice we have a half power, which basically is a square root, and then we have a quadratic inside of the parentheses, so that kind of tells you you're going to have to do a chain rule. Because there's something inside of that parenthesis other than just a singular x. So I got to use a chain rule. So let's do the differential here. So dy. Notice I'm not doing dy dx. I'm just going to do dy. I just got to remember put the dx on the right side after. The derivative of x squared plus 1 to the 1/2 starts off with a power rule. So half times x squared plus 1 to the negative half, because you got to subtract 1 from the power. And then you got to multiply by the derivative of the inside of the parentheses. So the derivative of the inside of the parentheses is 2x plus 0, or just 2x. I'm going to write dx right there. Now the half times the 2 will cancel out. And now I just got to rewrite this nicely. So let's see, dy is equal to, the x is going to stay on top. The negative half power, that's the square root of x squared plus 1 on the bottom. Right? Because that goes down and becomes a positive half, and a positive half power is a square root. And then dx, and this problem is done.